Hi, Calculus kids. This is Dr. Callahan. So, welcome to week 11, Wednesday. I hope you guys had a good Tuesday off. So, pause your video, and these are the 3 questions for your warm up block today. All right, so looking at this is the breakdown of your class in terms of the different categories. Your Math Excel is 20%, your final exam is 15%. Now remember, your Math Excel is your homework that you have as a practicing standard, and it's given to you every week. Like for example, this week is week 11, you have Monday, Tuesday, and you generally have 2 assignments on Wednesday and Thursday. There is no Math Excel on Friday, obviously. So make sure you guys are working on that. You actually do not have any exams, only just or quizzes. I just call them assessments. And together they are about 45%. And so we have them every single Wednesday, and they are always due on Sunday, or excuse me, 1 week, so every Tuesday, whereas your Math Excel is always due on Sunday. Your practicing standards, like your activities that we do in class, most everybody, as long as you're showing up on a regular basis, everybody generally get like 100% on the 15%, unless you're just simply sitting there, you're not participating in class when we're practicing everything that we do in class with the technologies like Kahoot or quizzes, or for example, if we're practicing in the video or in the guided notes. Participation, preparation, and warm up. This is your warm up block. You get 2 of them, one every quarter. So it's about 600 points, 300 points per quarter, and it is 5%. So that essentially is the breakdown of your class. All right, so let's go ahead and take a look at this. So last time I saw you guys, we talked about PVA, and this is the breakdown for today. So take a moment and review this. We are just about done with Unit 2, and we're going to move on to Unit 3. And Unit 3 is going to be the application of derivatives. Now, we have already started that with PVA. Another thing that we're going to talk about today, which is a little bit new, is word problems using derivative, which is also called related rates. These 2 questions are generally more difficult because it's more applications. But as we're going to go into Unit 3, we're going to talk about first, second derivatives with concavity, max and min, and inflection points. So that's kind of where we're going. Okay, so with that said, let's go ahead and get started. So take a look at your assessment for today. It is week 11, Wednesday. It is just 9 questions, multiple choice on College Board. It is going to be on PVA. So I highly recommend that you go back to our notes that we did in class or, on this YouTube video, hybrid-wise for week 11, Thursday. And then also week 11, Tuesday. On the Tuesdays, we talked about PVA because a lot of those questions are very similar to the transitions between acceleration, position function, velocity. It is due next, you have 1 week exactly, so it is due on week 12, Tuesday by 11:59 p.m. So just keep that in mind. All right, with that said, let's go ahead and take a look at the breakdown for today. So in your guided notes, you should have week 11, and it's going to be under Tuesday because we didn't have class on Tuesday because of election day. So we're just 1 day behind, even though I know today is Wednesday. This is your first page, second page, third page, fourth page, and 5th page. Now, you might not have the 5th page in there because I actually decided to squeeze this item in there. So if you're doing this on a hybrid day, you won't have this in there, but you're welcome to show your work on a separate piece of paper or even print it out yourself by just doing the screenshot, or you can ask me for a copy of it and I'll be more than happy to give it to you when I see you guys. Okay, so the first thing I want you guys to do is activity 1. You're going to need a highlighter, and I have flashcards on Unit 2. The formula is going to be on the left side, and it's match the answers on the right side. You don't need to cut anything. I just want you guys to highlight the ones you're not sure of. So with that said, take a look at page 1 and page 2 of your guided notes for week 11 Tuesday. So if you look over here, this is a position function, okay, and this is the back of it. These are the answers to it. Right now, you don't know what the integral formula means, but it's basically something we'll talk about in second semester. Integral is just a reverse of derivatives. So first semester, we talk about derivatives. Second semester, we talk about integrals. So we'll be working backwards next semester. I know, oh, fun. And we have a whole entire new set of formulas to memorize. That's not derivatives, but integrals. And so position function is going to be the first derivative of the position function is going to be velocity, or the position function is going to equal to the integral of velocity. So what I want you to do is grab a highlighter or even just a pen or pencil and take a look at some of these. See if you know if this is a term, this is the answer as of the concept. And the ones that you don't know, go ahead and start highlighting them. And then what you can do with this is if you take a look at page 3, you have boxes right here. You might want to write the ones that you don't know down so that way you can start memorizing them. We also have chain rules, derivative definition with the limits. Moving on to Rolle's theorem, mean value theorems, extreme value theorems. And then chain rule, quotient rule, power rule, product rule, etc. Derivatives of all of the chain rules with the trig derivatives. All right, so make sure you guys go ahead and highlight that. That is your first activity. So pause the video and get that done. You don't want to wait to the last minute to memorize all of your derivatives because come semester 2, we're going to have a new set of formulas like, integrals and whatnot. And so to be successful on the AP exam, you want to make sure you pace yourself and you memorize this with the allotted time that's given to you. You don't want to cram in April because it's not very effective. Activity 2. So I'm gonna give you guys 40 different review questions on Unit 2. I know it is tempting to just think about, oh, we're on PVA now, we're gonna forget about everything else. You can't do that. We're still gonna have to memorize everything from finding the limits, the algebraic, and finding limits analytically. You can't forget those things because you will be tested on your skill sets come May, and I want to make sure that you guys are adequately prepared. So I want you guys to give the answers. Well, the answers are pretty much given to you. It's on the first page of week 11, Tuesday on the left side. And the questions are located on the back of the last page for Monday. So just to make sure that you know how to do this. I also have the link right here in case you need, if you don't have access to the packet for some reason. But there are 22 questions on derivatives for Unit 2. And of course, the answers are provided for you as well. So go ahead and pause it, pick a few questions. You don't have to do all of them, but maybe pick some of the ones that you're like, I'm not sure if I can do this adequately. And then here are the answers as well, if you need to take a look and check your solution. Okay, I'm just gonna go ahead and go over number 9 with you guys, not because it's particularly difficult, but mainly because it has square roots and fractions. So first thing I notice is I don't like the way it's written, so I'm gonna go ahead and rewrite it as 2x, the 1/2, minus, let's go ahead and move the x up. So I have -1/2 x to the -1/2. Then when you find y prime, it's just a simple power rule, but you will have to use your exponent. So 2 times 1/2 is just 1, and then a -2/2, so it's a -1/2. Then I'm going to do the same thing over here, bring it down. So -1/2 times a -1/2 is a +1/4, -2/2 is a -3/2. So now that I'm done with the derivatives, I want to go ahead and rewrite this so it's a little bit more pleasing to look at. So I'm going to have a 1, bring that down, over square root of x, plus 1/4, and this can go down the bottom here. So I have an x. Remember, your power is your first part in the numerator, your root is in the denominator. So this will be power to the third power, and that will be your answer. All right, and then your last part of this is going to be related rates. So what I would like you guys to do is get to the last page, or actually, if you were at home, you wouldn't have that page, but if you were not, if you were actually with me, it will look something like this. So looking at this part right here, sorry about that. Let's go back to this. You should have this from class. And my screen share is paused. So let's redo them. Here we go. So go ahead and read this. Related rates is the other side of PVA. It's another version type of using derivatives and applying it to word problems. And here I have the steps given to you guys. So you are welcome to go ahead and read the steps, and then we will go over a few examples together. At first, when you're looking at related rates, it's going to look really, really complicated and difficult, but I promise you, as you practice more and more with it, you're going to learn that there is a pattern to how things are done, and you're like, oh, you know, that's not so bad. I feel like I did this before. It's just like studying with the SATs. The first time you look at some of the questions, you're like, oh my goodness, they're very strategic, and you know, there has to be an easier way of doing this, and there's always a way of eliminating certain answers, but the more you practice, the more you get the hang of it, the more you'll be able to see what the pattern set is. And with each additional questions that you attempt to try, it does get easier because you do see the pattern how things are done. All right, so let's take a look at example 1. It says the side of a square are increasing at a rate of 5 centimeters per minute. How fast is their area increasing? And the keyword here is area when the sides are measured at 15 centimeters in length. Okay, and this is related rates, obviously, and here are the steps. So step 1 says write what you are given. I know I'm talking about the area, and I know it's a square, so area is x times x, which is x squared. I'm also given that the rate of change is 5 centimeters per minute, so that's dx over dt, which is 5 centimeters per minute. So that's what I'm given. And it's also given to me that the sides of the square, so x, if this is a square, and this is an x and an x, these are the sides. Area is x squared, so one of the sides is 5. Okay, so that's what I'm given at this point. Or I'm sorry, the x is, hold on a second, the length is 15, not 5. 15, sorry. So now, write what you're trying to find, step 2. So my goal here is I want to find how fast is the area increasing when the size is 15. So I want to find dA over dt, which is going to give me something there, okay? And I also know that the formula for the derivative of a over dt is going to be 2x times dx over dt, because there are two sides, okay? And dA over dt, this part right here, is going to represent the change in area with respect to time. Delta, I should write change, although we use delta as change in physics. Change in area with respect to, so WRT. I should probably write that out instead of shorthanding it, with respect to time. So my goal here is just to find dA over dt. So let's take a look at this. 2x, because there are two sides, well, one side is 15, that's given to you right there, times dx over dt. Well, dx over dt is also given to you, it's right here, so 5 centimeters per minute. Now you just have to go ahead and multiply it out, and you're going to get 2 times 15 times 5, which is going to give you 150 centimeters squared, because we're dealing with area, per minute. Done with 2. 3, write the algebraic geometric equation relating to the variable, which we have right here. 4, differentiate the equation with respect to time, and then substitute and solve. All right, let's go on to the next question. It says a 20-foot ladder is leaning against a vertical wall. The bottom of the ladder is being pulled horizontally away from the wall at the constant rate of 3 feet per second. 2 parts of the question. How fast is the top of the ladder moving, and in what direction when the bottom of the ladder is 15 feet from the wall? And B, at what rate is the area changing when the bottom of the ladder is 15 feet from the wall? So let's first draw a picture of this. So here is my wall, there is my ladder, and here's my ladder. Here is my Y, and then here's my X. And remember, as you're pulling the ladder horizontally, it's going to extend the X. And then I know this is going to be my Z. I could use A, B, C, but I feel like X, Y, Z is better. But also you have the Pythagorean theorem as well. So your Z, what you're given is a 20-foot ladder. So that's given to you. Also, what's given to you is X, because the bottom of the ladder is 15 feet from the wall. So that's 15. Y, does it tell you about anything of the ladder with how tall the wall is? Well, you could go ahead and find that if you go ahead and use the Pythagorean theorem. So go ahead and apply the Pythagorean theorem to find y. All right, so let's go ahead and take a look at that then. Remember, your Pythagorean theorem is x squared plus y squared equals z squared. So you have 15 squared plus y squared equals 25 squared. And if you go ahead and solve that, you know, y squared equals 25 squared minus 15 squared. Y equals the derivative, or excuse me, the square root of 25 squared minus 15 squared. I actually don't know what that is. I don't have a calculator in front of me, but you guys can go ahead and do that. But just to be on a whim, since I've done this so many times, I know if it's the perfect square between 15, 20, and 25. So I know my y is going to be 20. Now from those things, I also know that my change in x, so dx over dt with respect to time. Oh, come on, work. Is going to be pulled horizontally, so that's going to be the x value at a rate of 3 feet per second. So then I want to find the dy over dt, which is part B, but I don't know what that is. And I also know that the dz over dt, which is a change of z, well, the length of your ladder is not going to change, obviously. It's not going to stretch out to be bigger or longer. It's just going to be the same. So that's going to be 0. But that's what I'm given. All right, so let's go ahead and get started with finding this. First, we'll start with finding how fast is the top of the ladder moving, what direction. Sorry. All right, just have to read that for a second. All right, so let's take a look at this then. So you know you have x squared plus y squared equals z squared. Let's find the derivative of that with implicit differentiation. So I have 2x dx over dt plus 2y dy over dt equals 2z dz over dt. Okay, and then from there, remember that you can go ahead and substitute some of the things back in there based on what they've given us. Now I know that my x is 15, so I have a 2 times 15. I also know that dx over dt is going to be 3 plus 2 times y, and I know that y is 20, but I need to find dy over dt equals 2 times z. Z is 25, and then dz over dt is 0, so it essentially just cancels that. And if you solve for dy over dt, because that's our goal, I'm going to have 2 times 20, which is 40, dy over dt equals, you're going to move everything here over to the right side, which is going to be a negative 90. And then when you divide it, 90 divided by 40 is a negative 9 over 4 feet per squared. And there is your answer. Okay, that is going to be your answer for part A, which corresponds to how fast is the top of the ladder moving and in what direction when the bottom of the ladder is 15 feet from the wall. All right, so then for B, at what rate is the area changing when the bottom of the ladder is 15 feet from the wall? Well, area, if you're looking at the area, it is of a triangle. So area of a triangle is 1/2 base times height, or in this case, it's 1/2. Your base is x and your height is y. So you would have to find the derivative of that. To find the derivative of this to get dA over dt, unfortunately, you will have to use the product rule. So I'm going to set it up over here on the side. We're going to go ahead and say let f be 1/2 x. So f prime is just 1/2. G is going to be y, so g prime is going to be 1, but it has to be a dy over dt. And then we have to do the same thing with the x, so 1/2 dx over dt when you're finding the derivative. So then when I go ahead and have f prime times g, that's going to be 1/2 dy over dt times y. So I have 1/2 dy over dt times y plus f times g prime. So here's f times g prime is 1/2 x dy over dt. So now I can go ahead and go back to substituting some of the numbers back in. We've already differentiated the equation with respect to time. So let's plug some of those things in. So I have 1/2 dy over dt is negative 9 over 4. I found that from the last one. Right here. Times y is 20, plus 1/2 x is 15, dy over dt, which is negative 9 over 4. And if you go ahead and multiply this part out, you should have a 30 minus 135 over 8. And if you go ahead and find a common denominator, which will make that a 1, but then the numerator, or excuse me, 8, and the top will be 240, you will have 105 over 8 feet squared because of the area over second. And that is your dA over dt. So to summarize, A, how fast is this moving? This is a dy over dt. Oops. And then the second part, B, the rate of change for the area is 105 over 8 feet squared per second. Okay. So let's take a look at example 3. All right, so I'm gonna have you guys try this one on your own. However, I'm gonna help you set this up. And if you guys take a look at this right here, it says a spherical balloon is being inflated at the rate of 10 cubic centimeters per second. Find the rate of change of the surface area, keyword, of the balloon at the moment when the surface area is 64 pi. Okay, so if the balloon is being inflated, you're not looking at the surface area, you're looking at the volume because you're pushing the air out. So the two formulas I'm going to be dealing with is volume, and I know you're like, why do we ever have to learn about volume and surface area in geometry? It's in preparation for this class right here. So if you remember, the volume of a sphere is 4/3 pi r cubed, and the surface area of a sphere is 4 pi r squared. So from there, you are given that when you're looking at the volume and you're deflating this balloon, the rate of change, so dV over dt, is going to be at 10 centimeters cubed per second. And what you can do here is you want to find the ds over dt. But it is given to you that the surface area of this balloon is at 64 pi. Okay, so then let's go ahead and take a look at this. In order to utilize this 10 centimeters cube, I will probably need to find the formula for the derivative of volume over dt. Okay, and guess what? The volume is right here. Your r is your variable, so I'm going to have to use the power rule. So I have 4/3, bring the 3 down, or actually I have 4/3 pi because we're constant. Bring the 3 down minus the 1. So I have times by 3 r squared. But then because I'm doing the derivative of r with the power rule, don't forget your dr over dt. Okay. Well, my 3 and 3 cancels because there's one top and bottom. So then I have 4 pi r squared dr over dt. So then if I go ahead and proceed with this by looking at ds over dt, I will just go ahead and repeat this one more time with the power rule. Bring the 2 down. 4 times 2 is 8 pi r to the 1 power dr over dt. All right. So now that I went ahead and have this, s is 64 pi, is going to equal to 4 pi r squared. Because your surface area is right here, and it's also given to you that your surface area is 64 pi. If I solve it together, I can go ahead, set them up together, and then attempt to solve for r. So that way I can plug a number in here for r and then solve for dv over dt and ds over dt. So let's solve for r then. Well, 64, or I can cancel out the pi. That's on everything. 64 divided by 4 is going to give me 16 equals r squared. So then r is going to equal to a positive and negative 4. Well, your r cannot be a negative 4. So the only answer you can have is a positive 4. And once I have that, I am going to go back to my dv over dt, which is going to show that I have my dv over dt is going to be 10 right here. Set that equal to my this dv over dt. So 4 pi r squared dr over dt. And now that I have the value of r, I can plug that in. So 10 equals 4 pi times 4 squared dr over dt. And what we want to do right now is we want to go ahead and solve for dr over dt. So you're going to have a 10. And my pen is being a little weird. 4 times 4 is 16. 16 times 4 is 64. Divide that over pi equals dr over dt. Which if you reduce that a little bit further by 2, 5 over 32 pi. All right. So find the rate of change of the surface area of the balloon. This is the change for the surface area of the balloon. And we're going to use everything that we just found. And the things that we found are, we found that the dr over dt is 5 over 32 pi. Oh, for crying out loud, don't do that. What just happened? Dr over dt equals 5 over 32 pi. Okay, so we have that. And we also have, actually, let's just start from there. Yeah, that's good. Okay, sorry. So then let's go back to the over here, ds over dt. So we have ds over dt is equal to 8 pi. R is going to be, when we found R, oh, it's 4. Yeah, that was the other one I was looking at. 4 right here. dr over dt, which is 5 over 32 pi. Okay, and then if you multiply that out, 4 times 8 is 32. 32 cancels to the bottom. Top pi cancels to the bottom pi. You're just left with 5 centimeters squared per second. And that is your answer. All right, you guys, let's go on to the next one. So for example 4 and 5, because those are the last two, I'm gonna give you guys a moment to kind of go ahead and give that a try. So you're welcome to pause the video because I will give you guys the steps for this as well. So just pause the video, answer question number 4. Okay, so let me go ahead and share the answer with number 4 with you guys. For number 4, here is your answer. Go ahead and take a moment and take a look at that. And I know some of these questions are somewhat difficult initially, but it really does take you guys a little bit of time to practice them to understand how this is done. Okay, now take a look at question number 5. Pause the video, give it a try to answer it. And then here is the answer for question number 5. And you really do want to take a look at some of these questions because last year I know they had a question on example 5. The previous year they had a question on example 2. And so they just kind of use the same 5 questions and they kind of circulate it back and forth. So make sure you guys take the time to understand this. All right, you guys, this was a lot of work today. I hope this helped. I know it's a little frustrating with some of these questions because they are hard and they are word problems, but we will keep practicing with them. Make sure you guys do your quiz on PVA for Wednesday. And as always, stay safe and healthy. Take care. I'll see you guys next time.